right, we are now looking at target 6.8. This is our last one. We are still using our midpoint formula, our distance formula, and our slope formula. But now we're taking our parallelograms and we're going to prove that it's a rhombus, a rectangle, or a square. Okay? So we're still looking at quadrilaterals. We're just now proving special. They're more special than parallelograms. Okay? So a rhombus. A rhombus is a parallelogram where all four sides are equal. Rhombus is not the word we teach children for this shape. The shape we usually say is diamond. So it's like a squished together square, right? But all of those are exactly the same. Okay? So it's a parallelogram where all four sides are equal. Okay, a rectangle is just a parallelogram where adjacent sides, again, adjacent means next to, are perpendicular. Okay, so if I draw a rectangle, right, it's a parallelogram. It has opposite sides parallel, all that. The only thing is this side and this side, they're next to each other, so they meet at a right angle, right? They're perpendicular. And that's true for all the sides. Then finally, a square. A square is also a parallelogram. Where all four sides are equal. And the adjacent sides are perpendicular. Okay? So it's just a parallelogram where all four sides are equal and the adjacent sides are perpendicular. Basically, it's a parallelogram that is a rhombus and a rectangle. Alright, so if it has all the properties of a rhombus and all the properties of a rectangle, then it is a square, right? If I look at our normal square, right, these are all equal, just like up there in our rhombus. Oops. And then all these are right angles, just like in our rectangle. Okay? So a square is the most special of the quadrilaterals. So a rhombus, right? Again, it's a rhombus if and only if it has four congruent sides. So that's how we're going to prove a rhombus. It's a rectangle if and only if these are right angles. Okay, so we'll use it with our, what's the word I'm looking for? Perpendicular, which has to do with slope, right? And then a quadrilateral is a square if and only if it is a rhombus and a rectangle. Okay, it has both those properties. So let's look at some examples. So prove that a quadrilateral with the vertices A, negative 2, 3, 2, 6, 7, 6, and 3, 3 is a rhombus. So negative 2, 3, 2, 6, 7, 6, and 3, 3. Beautiful. Okay, so the first thing, if you remember our definition, the definition of a rhombus is that it's a parallelogram that then has more properties. So our step one is to go back to what we did yesterday and prove it's a parallelogram. Okay. Depending on what you have to do for the specific shape can help decide which method will be easiest. To prove something's a rhombus, I need 4 congruent sides. So, I'm going to use method 2 for proving that this is a parallelogram, where I had to show opposite sides are congruent, because then I already have the distance of all 4 sides, and I already have all the work done. I'm then just saying, hey, look, these opposite sides are congruent, and then actually they're all congruent to each other. I'm done. So let's see. So method 2. Both sets congruent. Okay. So I'm going to go from, let's put some letters in. A, B, C, D. From A to B, that's 3, and then 4, okay? So, our distance for A to B, well, 3 squared plus 4 squared will equal our distance squared. So that's 9 plus 16 equals our distance squared. So 25 equals our distance squared. Since this is a nice perfect square, I'm actually going to say 5 equals our distance. Okay, so then I have to do the opposite side, C to D. Well, it goes down 3 over 4. Well, hey, look at that. 3 squared plus 4 squared equals D squared. There's my, these are congruent, but that's just my first set. The other ones are easier. The distance between B and C, B to C, done. I can count it, right? 1, 2, 3, 4, 5. Same thing with my distance from A to D. So these are congruent. That's my second set. So I can say, yes, this is a parallelogram. Done. Now I just also have to say, oh wait, are these all congruent? 5, 5, 5, 5. Yes. We have 4 5s. Done. So A, B, C, D is a rhombus. Because all 4 sides are congruent. Beautiful. Moving on. So that's for a rhombus, right? So that will work most all the time, right? Sometimes you'll have to find the distance for all 4. They won't always go straight across, but pretty simple. As long as you can find all 4 sides and say, yep, they're congruent, you're good. example 2. Prove this quadrilateral is a rectangle. So we have 1, 1, 5, 3, 4,
They call it median D208.
and 0, 3. Looks rectangular, but we do have to prove it. So, again, we still have to prove it's a parallelogram first, and we have to choose which method we want to use. For a rectangle, right, what do we need? Well, I need perpendicular sides, right? And by being perpendicular, I'm doing something with slope, right? Because I know parallel and perpendicular slopes. Therefore, I want to do something with slopes, so I might as well use our first method. Both sets parallel, right? Sorry. So if I use that first method where both sets are parallel, then I have the slope of all 4 sides, and I can easily check if they're perpendicular. I don't have to do more work afterwards. I also didn't put numbers. G, H, I, J. Okay, so let's go from G to J first. I'm going to go up and over, right? Well, I'm going to go up 2 and then left 1. Again, direction matters. So that's 2 over negative 1, which is negative 2. Then I'm going to go to our opposite side, H to I. Oh, good. It also goes up to left 1. And it's also negative 2. Good. Done there. Now I have to check I need both sets. So right now they are parallel. But that's just one set. Looking from J to I, not G to I. I'm going up 2, right 4. Okay, so I'm going up 2 over 4, which I don't know why I have a negative in there, sorry, which equals just positive 1/2. Hold on. The same thing with G to H. I'm going up 2 over 4. Again, just careful with your counting. It's very small, right? So we have to be careful. Again, colors could help, which is also 1/2. Okay, so that is parallel. One set. So yes, it is a parallelogram. All my 2 opposite sides are parallel. So now I just have to check that they are perpendicular. So I'm going to say negative 2 times 1/2. Well, that equals negative 1. And negative 2 times 1/2 does equal negative 1. Good. Perpendicular. Right? So if you kind of have it set up this way, you can just kind of go across and check those. They should be the same. So it's not much you have to check. But yes, that does mean those sides are perpendicular. So we're done. Okay? So GHIJ is a rectangle. Because all adjacent sides are perpendicular. All right, last example, example 3. Proving it's a square. That one's the most involved because it's the most special. So we have our point at 0, 0. Sorry. We have our point at 4, 3. 7, negative 1. And 3, negative 4. Alright? So with squares, we have to do rhombus and rectangle. So we basically just have to combine the two previous problems. I'm going to start with a rhombus by doing all 4 sides congruent. Okay? So we'll go from A to B. And that is 3 and 4. Okay. So for A to B, 3 squared plus 4 squared equals your distance squared. This will be nice. We have 9 plus 16. 25. And that is 5. I'll do the opposite side. Again, I'm always doing my rise first and then my run, simply for the slope that comes later, right? So from D to C, we have 3 squared plus 4 squared. Good, same distance. A to B, Y, X, that's negative 4, positive 3, right? Remember, your negative doesn't matter for your Pythagorean theorem, it matters for your slope. So I could still do this as 4 squared plus 3 squared. Okay. And that's fine to recognize that it's still just 3 and 4. Your distance is still just going to be 5. Same thing B to C. Negative 4 and 3. So again, that distance is 5. Great. I have all 4 sides congruent. Okay. Now I need to show that the 2 are parallel and that the adjacent ones are perpendicular. Okay? So I'm going to go back around, right? And now that I have distance, that's my rhombus, I need to do slope with my rectangle. Right? So then for A and B, well, it's 3 over 4. And that doesn't reduce, so I was going to say equals. Okay. And that's it. Slope isn't hard, right? Now this is where it's nice and easy if you actually draw in the x and the y every time, right? Your y and then your x every time. That now when you go back and do slope, it's all right there for you. So from B to C, well again I'm going 3/4, right? 3/4. Good. Those are parallel. That's what we want. From A to D, I'm going -4, 3. Okay. And from B to C, again, -4, 3. Now, any two of these I choose, right, any two adjacent sides that I choose is going to be 3/4. That's an arrow. Perpendicular. Okay, any two sides I choose, right, will be some, right, 3/4 times -4/3 or -4/3, right? They'll always be this multiplication, and that does equal -1, so they are perpendicular. Fabulous. We're done. A, B, C, D is a square because all four sides are congruent and the adjacent sides are perpendicular. And done. Okay? All right, that is it. I will see you guys tomorrow.